In the last video, I said that modern physics points to a beginning. Not just the beginning of stars, not just the beginning of galaxies, but the beginning of time and space itself. Physicists often represent that boundary with a simple expression. T equals 0. T stands for time, and 0 means there isn't any. Taken at face value, it marks the place where time itself runs out. A place where terms like where and when lose their meaning. But scientists have seen math break before, and this could be one of those times. It could be that T equals 0 is simply telling us that we need better math. Newtonian physics gave way to Einstein's general relativity. Right now, general relativity and quantum mechanics don't always get along with each other. This isn't a new pattern. On the other hand, even if future physics does come up with something that works it all out, the physical evidence still points to this universe having a real beginning, even if T equals something else. This universe has a finite past, a real boundary, a true beginning. By the early 20th century, scientists already knew there were serious problems with an eternal universe. Entropy alone created a massive issue. A universe that continually runs down cannot have been running forever. Otherwise, the stars would have already been burned out, usable energy would have already been exhausted, and the universe would already be dead. Heat death wasn't a small problem for an eternal universe. It was a massive one. Then Einstein developed general relativity, and his own equations pointed toward a dynamic universe, one that was either expanding or contracting. But Einstein wanted a static universe. So he inserted the cosmological constant to hold the universe still. And not everyone agreed. In the 1920s, Georges Lemaître took Einstein's equations at face value and proposed that the universe was expanding from an earlier, denser state. A few years later, Edwin Hubble looked through a telescope and discovered that the galaxies really were moving apart. The universe wasn't static after all. Still, many scientists were uncomfortable with the idea of a beginning. So in 1948, Fred Hoyle, Hermann Bondi, and Thomas Gold proposed the steady-state theory. The universe would expand, they said, but new matter would continuously appear, keeping the overall universe eternal and unchanging on the largest scales. It was an ingenious attempt to preserve an eternal cosmos. Then came 1965. Arno Penzias and Robert Wilson discovered the cosmic microwave background, the faint afterglow of a hot, dense, early universe. This evidence was becoming increasingly difficult to explain away. The universe appeared to have a real beginning. What's fascinating is that Fred Hoyle eventually recognized just how extraordinary the universe looked. Studying the remarkable fine-tuning required for carbon and life to exist, he wrote, "A common-sense interpretation of the facts suggests that a superintellect has monkeyed with physics." This wasn't a Christian apologist talking. This was one of the architects of the steady-state model. And yet the deeper we looked, the harder it became to avoid the conclusion that something very unusual had happened. This universe had a beginning. Why the resistance? Well, put simply, they and many others did not like the implications of a hard beginning. A hard beginning to physical reality draws a line. Once you arrive at that boundary, science has no subject matter to work with, no observations, no earlier conditions, nothing to measure. Science studies physical systems, but at the beginning of physical reality, there is no physical system to study. If you want to talk about why this universe exists at all, you've stepped outside the domain of science. Hard stop. If you want an explanation, you have to look to philosophy. And a lot of scientists are not comfortable with that. So explanations are still offered, and they're often presented as science, or at least not clearly distinguished from it. Some take the form of anthropic reasoning. Some treat the universe as a brute fact, sometimes with explanatory add-ons. But the most common approach is some version of a multiverse. And in most cases, it's grounded in a philosophical commitment to materialism. And that matters. because methodological materialism, the kind used in science, is a tool. It limits explanations to what can be observed and tested. Philosophical materialism goes further. It says that only material explanations are allowed, even when you're trying to explain how the material world came into being in the first place. The alternative is some form of theism. If this universe had a beginning, it didn't cause itself. So whatever caused it would not be material. It would be timeless, spaceless, immaterial, powerful, and capable of making a choice to bring a universe into being. Both of these are philosophical explanations. So at this level, we're not choosing between science and theism. We're choosing between philosophical explanations. For a long time after I left the ministry, I didn't see it this way. I assumed the multiverse was science, and that an agent or a mind was just wishful thinking. I spent plenty of time looking at what I thought was science, and plenty of time thinking everything else was just belief. There's a reason I saw it that way, and there's a reason a lot of people still do. Here's one concrete example. In 2008, Tim Folger wrote an article in Discover magazine titled, "The Infinite Multiverse, Science's Alternative to an Intelligent Creator." That's not subtle. It presents one explanation as science and the other as something else, when they're both something else. They're both philosophy. And to be fair, many scientists will say exactly that. There are scientists who are philosophically theists, but methodologically materialists. In fact, that's how science works. But when I actually compared these two philosophical explanations for why the universe began, I ended up with a theistic worldview. Because it's not just that this universe began, it's how it began. It began with an extraordinarily low entropy state and a very specific set of physical constants. For a universe to develop structure, stars, galaxies, planets, and people, it can't just start in any condition. It has to begin in a highly ordered state. How ordered? Roger Penrose calculated that the odds of a universe starting in a state like ours, purely by chance, are on the order of 1 in 10 to the 123rd power. That's not just unlikely. That's a number so large it's effectively beyond comprehension. And it's not just entropy. Constants like the cosmological constant, the strength of the fundamental forces, and others all fall within extremely narrow ranges that allow structure to exist at all. If those values were even slightly different, the universe would either collapse too quickly or expand too rapidly for anything to form. So this isn't just a universe that began. It's a universe that began in a very specific way, with the right conditions for structure, complexity, and life. This isn't just a beginning. It's a calibrated beginning. And something important, the idea of a multiverse didn't come from observation. It emerged in the late 20th century as an extension of certain theories, first in quantum mechanics and later in cosmology through inflation. And over time, it became a way to explain why this universe looks the way it does. Now, when you actually look at the options on the table, they really fall into three categories. There's the multiverse, which actually tries to explain it. There's the anthropic principle, which doesn't explain it. It just tells you why we would expect to see a universe like this if there are lots of universes. And then there's brute fact, which basically says that's just the way it is. So, in practice, if you're staying within a materialist framework and you're actually trying to explain fine-tuning, the multiverse is doing the heavy lifting. The anthropic principle tells you why you'd observe it. Brute fact stops trying to explain it. The multiverse is the only one that even attempts to account for it. And that's not a fringe idea. Remember that 2008 Discover magazine article by Tim Folger, The Infinite Multiverse, Science's Alternative to an Intelligent Creator? It says it all. So now you need a mechanism that can generate a vast number of universes. Quantum fluctuations, quantum foam, big bounces, quantum branching, or something we haven't even thought of yet. And whatever that is, it has to produce entire universes, laws, constants, structure, everything, because that is what this universe has. If not, you wouldn't need a multiverse at all, but it does. So the question becomes, does that generator have a beginning? If it does, we haven't solved the problem. We've just moved it. We've gone from explaining this universe to proposing something even larger that still needs an explanation. And whatever that is, it has to be at least as finely tuned and even more vast than the universe it produces. Now think about it the way that Discover magazine title framed it: an infinite multiverse. If it's infinite in extent or duration, then you're dealing with something that doesn't have a clear beginning. And that creates a whole new set of issues. It would have to be generating universes indefinitely into the past. Otherwise, we wouldn't be here now. It can never run out. It has to remain stable on average, not collapsing, not flying apart, indefinitely. And all of this happens randomly without purpose. That's the materialist explanation. The other broad explanation comes from a theistic worldview. It posits that a timeless, spaceless, powerful, decision-making mind, an agent, brought this universe into being. Either just this universe or at least this universe. Anyway, no other universe is required. Is that a God of the gaps? No. The God of the gaps is when God is invoked to explain what is happening within the physical world. Gaps in our knowledge of how things work. This is something different. This is an explanation of why a physical world, one that has a beginning and is extremely finely tuned, exists at all. And as I looked at those options, I just couldn't buy into a perfectly balanced, ceaselessly producing, endlessly emitting multiverse producer. It just makes more sense to me that a personal agent would bring something like our universe, one that includes a beginning with finely tuned fundamental constants, into being. One with not only physical laws and structure, but people with thoughts, relationships, questions, and the ability to reflect on all of this. But where do you land? Are you where I was looking at the multiverse as a scientific explanation? Do you find a multiverse to be a compelling explanation of how our universe began? Because these explanations are not the end of the story. We're not done. In the next video, we'll take a closer look at life. It's called It Looks Engineered. Hey, if you know what's good for me, you'll like and subscribe. And leave a comment. I'd love to hear from you. See you next time.